So this question here, I've got a particle t moving in a triangular direction. So we've got the vertexes labelled as A, B and C. So it's going along in this direction. There's a fixed point origin here which we don't know too much about. Now we're given that the velocity vector of t is 3i plus root 3j meters per second from A to B. So that's the velocity vector for that part. Velocity vector of t for B to C is minus 3i plus root 3j meters per second. So similar, but with a change in the sign of the I component. And then we've got this other information here. ABC is an equilateral. T returns to initial position after 9 seconds. And vertex B has position vector 1, 0. Now we want to find the speed of t as it travels from A to B, the angle ABC, and find the vector, position vector of the vertex C. So that's that part there. So how are we going to do that? Well, first of all, find the speed of t as it travels from A to B. So part A, speed. So for that, all we need to do is find the length of this using Pythagoras. Now we're given 3i plus root 3j. So the direction of each of these vectors is according to this diagram. So if we just draw a line across and make a right angled triangle, we've got our I component is value of 3. So that's value there is 3. And the j component is root 3. So by Pythagoras, to find this A to B, so A, B, that just equals square root of this one squared plus this one squared. So we've got 3 squared plus root 3 squared. Now 3 squared is 9, root 3 squared is 3, so we've got square root of 12. And to break that down into, we're using surds, we've got root 4 times root 3, so it's 2 root 3. So that equals 2 root 3. So velocity vector of t is root 3i, and find the speed of t as it travels from A to B, so it's 2 root 3 meters per second. So that's part A taken care of. That was pretty straightforward. Okay, now find the angle ABC. Now we know it's an equilateral, so we should get 60 degrees as it's an equilateral triangle. But let's try and prove that. So to do that, we need to find the angle here. Now this angle here, we could calculate that with this angle here and drawing a straight line across. This part of the angle here, we'll call that phi, is the same as this angle phi. They are going to be the same for this part here. And then this part here, we can calculate that if we just draw a right angled triangle again here by using Pythagoras for this velocity vector which we're given here. So let's go with that. So part B. So the angle of this one, well, if we use the j and the I components, we know the inverse tangent. So tangent is opposite over adjacent. So that angle there is inverse tangent of root 3 over 3. So if you divide everybody by root 3, we get, let's just write down the phi equals. So we then get phi equals inverse tangent of 1 over root 3. Now we know that's a standard trig value in our unit diagram. That one there is 30 degrees. So that one there's 30 degrees. So we're happy with that. Now this one, let's calculate this one. So B to C is minus 3 and root 3. So the I component is 3. So we take the absolute value. So we can't have a distance that's minus 3. So that distance there must be 3. And the j component is root 3. So this one here must be root 3. So that's going to give us a very similar calculation to what we've got here. So that's going to give us this one here is also root 12, which is 2 root 3. Okay, now we want to find this angle here. Let's call this one theta. So angle theta equals inverse tangent. So opposite over adjacent, root 3 over 3. So we've got root 3 over 3. So which is going to give us the same as this calculation here, so it's 30 degrees. So therefore phi plus theta equals 30 plus 30, which equals 60 degrees. Hence we've shown that this angle here is 60 degrees, and this speed of travel as it goes from A to B is 2 root 3. So that's the first parts of the question taken care of. Now we want to find the position vector of vector C, vertex C. So this part here. So what we do is we take this off the board and then we'll move on to this information here. Okay, so let's move on to part C. Find the position vector of vertex C. So we've got ABC is an equilateral triangle. T returns to its initial position after 9 seconds. Now, if it takes 9 seconds to travel around an equilateral triangle and its speed is constant, therefore we've got 3 seconds per side. So it would take 3 seconds along here, 3 seconds along here, and 3 seconds to travel along there. So that would give us our 9 seconds. Now vertex B has position vector 1, 0. So this one is 1, 0. And that's in terms of our origin. Now we want to find C. So how are we going to do that? Well, so if we've got the speed and we've got the time for which it travels, we can calculate the distance. So let's use that principle when trying to find out this position of vertex C. So this part T here, it's gone from A to B. So A to B, and it then goes from B to C. So we can add these position factors up to give us our A to C. Okay, now we already know that when it gets to the point B, the position vector is 1, 0. So basically we've got 1, 0 plus whatever we can calculate for BC. And then that position there will give us our position at C. So how are we going to do that? Well, if we write this as a vector in this format, we can then take care of that. So therefore we've got 1, 0 plus, well, it travels for 3 seconds, so that can be a scalar value. And the velocity vector from B to C is -3 and root 3. And that will give us our position at C. Let's just leave it like that for the moment. So let's just simplify this up. So 1, 0 plus 3 times -3. So that gives us -9. And 3 times root 3 is just 3 root 3. Let's give ourselves a bit of space to write that in. Okay. Now just simply add them up. So 1 plus -9, so adding up the I components. So then that gives us -8. And 0 plus 3 root 3 is just 3 root 3. So then that's our position of vertex C in comparison with the origin. So therefore that's where C is at this point here. So -8, 3 root 3. So let's just write that there. -8 and 3 root 3. That's the position of that vector there. Okay.